recording. That's good. Go into OneNote. Really go into OneNote. So relative motion or relative velocity is often the part that we focus on. We want to go into a drawing thingy. Any choice of colours? Blue, black,
Purple, green,
purple. Let's keep it easy. One of these ones, eh?
red.
Someone say black. Okay, good. So black it is. Did you really have an option? I don't know. So, first of all, since we're dealing with vectors, we're going to draw a vector equation. And this is going to be the start of every relative velocity or relative motion problem-solving strategy. So we've got v, or the velocity, of A relative to B, I'll write this out in full underneath as well, equals the velocity of A minus the velocity of B. And remember, you don't need all the curly bits on the V's and things. That just is something that I've developed as a habit. Sometimes you'll see the little wiggly lines underneath to show that these are vectors. Sometimes you'll see a little arrow over the top in other parts, but that's just a reminder. So let's detail what each of these is. How we would think of this in our mind, because it looks a little bit weird when we just look at it right there on the board. The velocity of A relative to B means if we have two cards, or two blocks that look suspiciously like they're trying to look like cards. Yeah, it does. Got a smiley face here. Yeah. Let's. I normally put an exhaust pipe on so people know that it's a car. But that just looks like a bit of hair sticking out over. Once you see something, you can't unsee it. We'll have it going in this direction. 10 meters per second. Sorry, the resolution's probably not going to be the best for our purposes. And let's have another car going towards it. Another hat going towards it. And it did have an exhaust pipe too, so we know. I don't know. I can't stop seeing this hat now. Okay. So the velocity of A relative to B means we are looking at the velocity of A as seen from a person who is in car B, if it's this case with the cars. So that's an important thing to think about. Imagine you are sitting in here driving, or as a passenger perhaps, because you don't want to do physics and try and drive at the same time, you might crash. You're sitting in there looking at this other car, and you want to see what velocity it's going at relative to you. So as far as you're sitting in car B, car A looks like it's coming towards you at what speed? 25 meters per second, yeah. Because when we're looking at the velocity of A relative to B, B is moving, A is also moving, but in the opposite direction. That one's going that way. It seems if A was sitting still, B going towards it would see A coming towards it at 15 meters per second. But since A is also coming towards with its own velocity, the two kind of add together. Okay. So that is a big fancy way of saying the velocity of A relative to B. Okay, let's just put in little brackets here. A's velocity and B okay. And VA and VB are self-explanatory, except, let's go for another colour, green, except remember when we have a vector subtraction, we want to go to make it a vector addition. So it would be VA plus the negative of VB. And just to also make another little note about that, negative means we change direction. And so in this example here, VB is going to the left. So we want negative VB, so it's going to be to the right. And they are the same size, same magnitude. Okay. Just wondering how to scroll down with this. Let's go to blue. And let's just work out the velocity of A relative to B. In this case, we already know it's going to be 25, but we want to do our subtraction and go through the process. Okay. So VA, how do I make it scroll down or something like that? Gone too far? Let's see if we can bring it up. That's far enough. So, first of all, same as when we're dealing with a numerical equation or kinematic equations, we write down what we know. We know VA is equal to that, and it's 10. Okay, just keeping the units out of it at the moment. Give our focus there. We know that negative VB is that, and I've made it slightly longer. It's not to scale, but it's just showing that it's bigger than that, and it's 15. Okay. So now if we do our vector addition, we're just adding those two things together. Even though one of them is negative, remember that's just a quantity in a direction. If we take those together and do VA plus minus VB, we get, I'll put the equals down here, 10, 15 gives us 25. And we write a resultant vector, but over the top of that, you might draw it with a double arrowhead or double along there. Something to indicate that it's the resultant on 25. And final answer should have units. Okay. So, in the simple case, we've got a one-dimensional problem. Or two-dimensional problem. I don't know. It's going that way and that way. Like a number line, it's very easy to work it out in your mind what's happening. And we got the same answer when we worked it out in our mind. If we're sitting in B and we see the car coming towards us A, it'll appear to be going in that direction at 25 metres per second. Your final answer doesn't need to have minuses and things if you've got a diagram to show very clearly which way it's pointing. Because remember, you can't deal with minuses as a way to show direction as soon as you move out of that one single line, because you can't show something being negative if it's going on a slight angle. But we'll come to that a bit later. Does that seem pretty straightforward? So what I want you to take out of this is the pattern of doing these questions, because we're going to do another example that'll be two-dimensional now, and we can't do it as instinctively, and we can't deal with the negatives and positives in quite the same way. So, let me go down that way. Yep. The example in here is the driver, motorcyclist and rain. I want to do that one. That's on page 100, and right down the bottom, the example R for racing on your motorbike, or R for rain. I don't know. See what I did there? Thinking out. Yeah. We'll go to red just because we want to mix up the colours. PG. Motorcycle. This is how I draw a motorcycle. I've never drawn a motorcycle on here actually, so I'm a bit stuck. Let's make it look vaguely like a... And then we'll colour this in. That's not too bad, eh? That's alright. And it's going to have an exhaust pipe. No, yeah, it's a back pipe. That's it. Person sitting on it. And they're probably sitting like this. And their arms there. And you can't see their face yet because it's a helmet. Oh, yeah, it should probably be bigger than their head, eh?
Stick man figure.
If I say motorcycle and you see that, you think motorcycle, so it's fair enough, isn't it? Okay. So 50 kilometres per hour. And we had some rain. Rain coming down at 15 kilometres per hour. So what do we want to find? Velocity of the rain relative to the cyclist. Find V rain, let's just stick with my little term relative to the bike. Okay. Some interesting noises. What was I going to ask? No. We'll write this down. Velocity of rain relative to the bike. What's our rule? If it's velocity of A relative to B, it's the velocity of... Good. So V rain minus V bike. Some very interesting noises. We don't need the wiggly lines underneath, just to show you that you don't have to have them. How's that going to change? Plus, because we want it in plus, V rain, negative V. Okay, go down a wee bit. Okay, we don't want to lose our cool bike in pictures, so we'll leave it like that. Have a colour, choose a colour. Purple. Green was too far. We can't do purple yet. I've got to set up the purple colour, otherwise I'll just highlight everything. Okay, so V rain, let's write down V rain, that's easy. We've got 15. And V bike is that way, 50. But we want negative V bike, which will be negative 50. Okay, so so it's a little bit pointless having the negative, to be honest. So let's just make a little note about that. In some ways it's sort of a double negative because the arrows change direction and we've got the negative on there. So we'll just leave it as that. Okay, so following the process, going back to green, let's add them together. We're going to take, no, I can't really draw arrows to show these, can I? So I'll draw a wiggly line. And just to show it's not a vector. And another wiggly line. So the sum of them together, V rain plus minus V bike. Top to tail. Okay, minus V bike. That's 50, that's 15. And then this. Yep, Pythagoras, 90-degree triangle. So 50 squared plus 50 squared Screw in all of that equals, what was the answer? Someone has it? 52? 52 to two significant figures. Two SFs is a fairly reasonable one. If we gave it at one significant figure, that would have it as 50, which is the same as the other one. And so 52 gives us the most reasonable solution there. Now, what's missing? Direction. Okay, we can see a direction if this was a scale diagram, but we want to work out an angle. That's generally you go from the horizontal, but it depends on what you're after. So we're going to go from, cool, we've drawn a diagram, we've added theta on there, so we'll find out theta, and then it's a bit easier. So theta equals what? We've got the 10, well we could use any one that we want now. Okay, use the unrounded values because it's a bit easier that way. So what are we doing? Inverse tan of, which is, that's how I think in my mind, almost exactly. I'll say these questions to myself. And what does that give us? 1.7?
That's fine.
Yep. 10 degrees to two significant figures. Cool, and that's it. Are there any questions?
Could you just pull up to the top and
Sure. Say when?
There's top.
You wanted to ask a question about?
No, it's still something green.
Oh, okay. Well, I'm going to stop recording. Which is that one? Oh. It's that one. And